Hello again, everyone. Welcome to this talk by Dr. Kufel from ARM Research in Cambridge. It's going to be really an exciting talk. He'll be telling us about, the trend towards natively flexible ICs. Just a quick reminder, there are two parallel sessions going on at the same time, so you can join each of them as you please. The networking lounge is also open. We'll ask Dr. Kufel to also enter the networking lounge after this presentation. We ask the questions live, so if you have any questions, type them in on the right-hand side, and we'll ask all the questions from the audience. The presentation is around, I think, some 18-20 minutes, and then the room will stay open for an additional 10 minutes to answer any questions that you may have. So without further ado, the stage is yours, and I'll disappear.
Thank you very much. Thanks, Kasia. Thanks for the introduction. Thank you for the invite. My name is Jedrzej Kufel. I'm a staff research engineer at ARM in the research team. I'd like to talk to you about the natively flexible ICs. So for those of you who are not aware of ARM, not familiar with ARM, it's predominantly a processor IP company. And I thought instead of giving you a company pitch, what I wanted to underline is the fact that the strength of ARM over the years have come from the ecosystem of partners, and ARM wouldn't be where it is today without it. And I think it's very important for the future growth of the flexible and printed electronics. In terms of what we do in the area of flexible electronics in research, we work on the algorithms, we develop hardware. We also designed our own standard cell library, and we do the characterization of that as well. We also do the full implementation flow from the RTL over the way to the GDS2. In the area of material and device development or the fabrication, this is where we collaborate with our partners, because this is what we don't do on our own. So let's focus on the flexible smart systems. What is it? It's an electronic system made of discrete flexible electronic components on a flexible substrate. And if we and the flexible in here, actually, because it's quite many names we've called it so far. The flexible actually here refers to the printed, organic, or any thin film-based electronics. So if we consider the physical properties, it's usually low cost, it's conformable, it can be stretchable as well. Usually it's of a small form factor, and ideally it would be energy neutral, where we have some sort of energy harvesting. In terms of in terms of the capabilities of the system, it usually senses something, some sort of temperature or humidity, does the storage of either the results that it's trying to sense, does some sort of processing, some sort of data acquisition, or some sort of analytics, and then it communicates it to the outside world. And in terms of the idea behind this sort of flexible smart system is that because it's low cost and conformable, we could potentially produce billions of those devices. However, as I mentioned also in the case of ARM, we also need this ecosystem where each company is responsible for various parts. And we also need companies who do the integration, because I don't think we have many at the moment. I think that is just the system. If we consider the processors, so if we focus on processors, we also need to mention that we need the support of the EDA tools and the modeling. We need various foundries and standards. And in here, I'll just focus on foundries for a second. So while we do have many research institutes and universities where there are some relatively small foundries, we do lack a lot of mainstream high volume foundries for the flexible processors. I'm not talking about silicon here. In terms of the EDA and modeling, I'll just focus on it a little bit later. So what kind of processor options do we have today? So on one hand, we have the hybrid integration, where we